Greetings everyone. Today I am here to present our final year project. The project title is Breaking RE-Captcha through Pattern Recognition. Our mentor is Professor Sanjeev Kumar. Project ID is 2017 CSE PID 16. Our team consists of 3 members, Mohit Pandey, Muskan Jain, and Prashant Kumar. Let's delve into it. Let's start with the introduction. CAPTCHAs have been widely used by websites to prevent their data being automatically updated by machines. By supposedly allowing only humans to do so, RE-CAPTCHAs have taken advantage of the reverse Turing test, knowing that humans are more intelligent than machines. The main purpose of RE-CAPTCHAs is to distinguish between humans and machines in security applications. The objective of our project is to determine whether current OCR systems, that is optical character recognition systems, are intelligent in terms of AI. We aspire to set standard for current CAPTCHA breaking systems and prove that TT is a good intelligence test regardless of its many criticisms. Now, going through the process of breaking CAPTCHA, we have divided our entire project into 3 modules: pre-processing, segmentation, and recognition. Most text-based CAPTCHAs have been broken by softwares like OCR and segmentation softwares. Other CAPTCHAs were broken by streaming the test for unsuspecting users to solve. Let's understand a normal image broken by a CAPTCHA breaking system. It first goes through a convolutional layer, which does the process of max pooling. Then it goes to another layer of convolutional that does the more optimizing. Then we have a hidden fully connected layer, and finally the output fully connected layer, which decodes our character. Let's go through the sequence diagram. As we can see through the diagram, the attacker requests a registration page to the target site, and then it requests the CAPTCHA frame from Google CAPTCHA. The request is returned with a CAPTCHA image. Then the CAPTCHA image goes to the anti-gate, which is this anti-gate is something which we have constructed through our project. This anti-gate queues the CAPTCHA image to a CAPTCHA solver, and then requested text is decoded and sent back to the attacker. This helps them to break the CAPTCHAs and enter a secure domain through sitting at a remote location. This is the workflow diagram of the CAPTCHA system. Now, this is another illustration of how our project goes through training our system. This is a normal training input. Now, firstly, let's go through pre-processing. In pre-processing, we do many tests like contouring and changing the intensity of lights in our picture, which enhances it and makes it proper for the next step. Next, we go through segmentation. The segmentation process breaks our CAPTCHA into different characters and groups them into different folders, which is used for training on a single character. Next, we go through the final step is deep convolutional neural network, which trains our system and produces an expected output when another set of data is input into it. Our technology stack includes Python, OpenCV, Keras, TensorFlow, and NumPy. We use the following stack because it was convenient to use them for a low-code system, and it had many inbuilt libraries for implementing an efficient convolutional network. This is our data set. As you can see, we have used a data set of almost 10,000 items to train our network, which makes it quite efficient. Next, after the segmentation process, the system breaks down the training data into different characters and makes different folders for them. Next, we have module 1. As you can see, this is the pre-processing module. This is the segmentation module, and this is the final training module, which produces the output. Now, why do we want to make this project? The main scope of this project is to determine the security that is provided by RE-Captcha to the system or application on web. Basically, RE-Captcha were used to distinguish between a machine and a human. But if machines become smart enough to break through RE-Captcha, then bots can again be used for searching email addresses, file web scraping, polls, and many other things like spreading viruses or mining cryptocurrency. So we aspire to set a standard for a CAPTCHA system. We aspire to make a threshold to make it pass as an efficient system. These are our references which we used during our project. Thank you. Now we would like to go to the demonstration part, which will give you a live demonstration of the project.
Thank you, Muskan. So now we start from our live presentation of our project. Okay, so let's see. So these are our files, like extracted single letters from the CAPTCHA images, helpers, and these are our Python files. This is where we have our extracted letter images after running this code. Okay, this is for pre-processing, and this is our data sets, which is around 10,000. These are data sets on which it will train and work accordingly. So now we can see here what's there. There is a CAPTCHA image folder, generated CAPTCHA images, which is our data sets. There is output folder, which is our extracted letter images, which is now empty because it isn't run yet. After running it, we will get some output, and we will show you after that. And this is our loop starting from it's taking files from generated CAPTCHA images and looping over it, and then converting into grayscale, and then again converting and taking their contours and working on it. After that, we will get a letter of image regions, which is a set and list, and in this list we have all the images region, which will be helpful in training model. And so after that, what this is here, we can see that this is where letters is sorted and set into letter image regions. And after that, when we start this project, let's run this and see what happens. Yeah, so now our image is processing. Yeah, it's around 9,955 files on which it will iterate, and we will get our output. So we will wait for some times. Yeah, so now we have all the images processed, and let's go to the folder and see what happens. Yeah. So these are data sets which I showed you earlier. And now let's move to this extracted image letters. And these are our extracted image letters, types of tools, how many type of tools were there, and these are the letters we can see accordingly. These all are the same, A to Z and 2 to 9. These are all the letters that our project found in the data sets. And now let's go to the code. So after extracting these and processing these files, now we have what we have to do is train our model so that we can use it for solving the CAPTCHAs. So this is our training model in which we will have our letter image folders, extracted letter images, model file name, and model label file names. So model file name and model label file names are two different types of files, HDF5 and DAT file, which will be after training the model. And in this, we are using Keras for training purpose. And here we have images from the letter image folders, and we are iterating over it and extracting each images from that folder and After that, what we will have, we will grab the labels, which is the name of the image, which I will show you. Yeah, this is the name of the image. It will grab it and helps to label the data. After labeling the data and setting the data, what we will do is build a neural network. In building neural network, we have earlier told you about the steps in which we will make convolution networks, max pooling and second convolutional network, then hidden layers. So here we are making the convolutional network with max pooling. So this is our first convolutional network, then second convolutional network, then hidden layer with 500 nodes, and then the last is output layer. So after doing this, we will have these two files created, which will help in our solving the CAPTCHAs. These two files, hdf5 and .dat file. Let's see. Let's run the file. Yeah, now we can see that our TensorFlow is working and data is training. It will take a 1 out of 10. We can change it also according to our need. So let's wait for its completion. It will take some time. So now this is the last step finally, and we will get our result in .dat file and .hdf5 file. Now let's go. Yeah, now it's complete. Now let's see whether the file is made or not. So now you can see here there is a model labels. This is, and also there is a .dat file. This is the .dat file we can see, and this is .hdf file, which will help in solving the reCAPTCHAs after the training. Now, last part, which is solving the reCAPTCHAs. Okay, so now in this file, we have these models, hdf5 and .dat file, which was from training model, and we will iterate over the images, which was here in the data sets. So what is here, it's, you can see that we are iterating over CAPTCHA image files, and we are getting the image, we are converting into grayscale, and then finding its contour, and then check whether it's equal to the training model and not. And after checking each and every aspect, we get the final output, which is the answer for the CAPTCHA. Yeah, so now let's see what's happened. And yeah, you can see that CAPTCHA text is 8UNB, and wait for it. This is the output, 8UNB. This is the CAPTCHA. Okay, then for next we will check like this UMP7. We are getting the text file here and the images here in the output field. So finally, this is our project, final year project. Thank you.
Thank you, Mohit. That was a very good demonstration. Let's end on the note that while CAPTCHAs may seem a little obsolete, but they have a huge potential unexplored, and we would like to explore it more. With that, we conclude our presentation. Thank you.